Students, today we are going to see the valence bond representation for the complexes with coordination number 6. That is octahedral complexes. These octahedral complexes have the two types of hybridization, D2 Sp3 and Sp3 D2 hybridization. So out of that, first we are going to see the complexes with the hybridization D2 Sp3. So first we see here octahedral complexes with D2 Sp3 hybridization. Example of this type are CONH36 3 plus, FeCN6 3 minus, MnCN6 3 minus, CrNH3 6, CrCN6 3 minus, COCN6 3 minus and CrCO6. So first example, that is CONH36 3 plus. Here central metal atom is cobalt. Its atomic number 27, electron configuration is AR core completed, 4s2 3d7. Oxidation state of CO is plus 3 in this complex. So CO3 plus, its electronic configuration, now 3 electrons are removed from the valence cell and we have the electron configuration 4s0 and 3d6. See its ground state. In the ground state electronic configuration of CO3 plus, it is 4s0 3d6. So here we are going to see 6 electrons, so 1, 2, 3, 4, 5 and 6. See here, hybridization is the D2 Sp3, that means 2d orbitals, 1 s orbital and 3 p orbitals take part into the bonding and that orbital must be empty. But here these orbitals are not empty, so it must undergo the excited state. So here we are going to see the excited state. In the excited state, see this electron is entered here and this electron will be entered here. And in the excited state, we have the situation like this. Here there are 2 electrons, here there are 2 electrons and here there are the 2 electrons. And then it undergoes the particularly, see this D2 Sp3 hybridization. See, once it undergoes the D2 Sp3 hybridization, it shows octahedral geometry. See, in that 6, here the first ligand, second ligand, third ligand, fourth ligand, fifth ligand and sixth ligand, they can donate the electrons to the central cobalt ion. And we have the bonding state. In the bonding state, see, this arrow indicates that it is the electrons of the cobalt and this cross indicate the electrons from the ligand. So first NH3 can give 2 electron, second can give the 2 electron, third NH3 also gives the 2 electron, fourth also gives the 2 electron, fifth also gives the 2 electron and sixth also gives the 2 electrons, and thus these are the particularly electrons from 6 NH3 ligands. 6 NH3 ligands. See, once it undergoes this hybridization, bonding is like this, and now this valence bond picture shows that there is no any unpaired electron. All electrons are the paired, and as the all electrons are paired, this compound is diamagnetic. This compound is diamagnetic in nature and its mu value is the 0. Here n value is also the 0. As the n is 0, mu is the 0. Mu is the magnetic moment. Mu is the magnetic moment. And when we are going to see the geometry of this complex, see the geometry of this complex, it is the octahedral geometry. See the octahedral geometry. 4 ligands and metal atom, they are in the same plane. They are in the same plane. So here 4 NH3 and this cobalt metal, they are in the same plane. One is above the plane and one is below the plane. So it is the structure of this complex, that is CONH3 3 plus with hybridization D2 Sp3. Then we are going to see the second example. See FeCN6 3 minus. Fe, its atomic number is the 26. Its atomic number is the 26. Electronic configuration, argon core completed, 4s2 3d6. Here Fe shows plus 3 oxidation state. So its electronic configuration in plus 3 oxidation state is 4s0 and 3d5. Its ground state electronic configuration, that is 3d, 4s and 4p, 3d5, 1, 2, 3, 4 and 5. See, in this particularly D2 Sp3 hybridization, these two orbital must be empty. So it shows the excited state, and in the excited state it shows that these two electrons will be shifted and they will be get paired, and here one electron will be remains unpaired. And so in the excited state, see, after shifting two electrons, here two electrons are paired, two electrons are paired and one unpaired electron is remains as it is. And here empty orbitals, two empty orbitals, one empty s orbital and 3p empty orbitals, they can shows the D2 Sp3 hybridization. So here we having the D2 Sp3 hybridization. See, in the excited state, there are the 6 empty orbitals. That 6 empty orbitals will be occupied by the electrons from the ligands, and thus there is a bonding will be occurs. And as in bonding state of Fe3 plus in FeCN6, see, these are the arrow indicates that these are the electrons of the Fe, and cross indicates that these are the electrons of the Cn minus ligands, and thus they occupy the first Cn, second Cn, third Cn, fourth, fifth and sixth Cn minus ligands. They gives the electrons and they will be get fulfill, and we having this picture. When we consider the valence bond picture for this, it indicates that there is one unpaired electron. One unpaired electron means as there is the unpaired electron, this complex is the paramagnetic, and that complex have the magnetic moment. So here n is equal to 1 and we have the magnetic moment, that is mu. So magnetic moment mu is equal to formula, that is n in bracket n plus 2. With the help of this formula we can calculate the magnetic moment. Here n is the 1, that means there is one unpaired electron. So here this value will be fill up in this formula, and we having the particularly this, that is under root 1 in bracket 1 plus 2. So it is under root 3 and it is equal to 1.73. Unit for this is the Bohr magneton. So this complex can shows the magnetic moment 1.3 Bohr magneton, and this complex is the paramagnetic. Now we are going to see its structure or geometry. See, when we consider the octahedral geometry, in the octahedral geometry 4 ligands and metal atom are in the same plane. Fifth is the above the plane. Here metal atom is the Fe. See, these are the 6 ligands. Out of that, these 4 ligands and metal atom, they are in the same plane. One is above the plane and one is below the plane, and thus we have the particular this, it having the 3 minus charge. So it is the complex, that is the Fe CN6 3 minus structure, which is called as the octahedral structure. See here, second type of octahedral complexes, that is complexes with Sp3 D2 hybridization. In previously we see the octahedral complexes with D2 Sp3 hybridization, and now we are going to see Sp3 D2 hybridization. What is the difference between this D2 Sp3 and Sp3 D2? See, this D2 Sp3 means it uses the 3d orbital, 4s orbital and 4p orbital. When we see Sp3 D2, it indicates that there is the 4s orbital, 4p orbital and 4d orbital. So it uses the d orbital, it is D2 Sp3. When it uses the 4d orbital for the hybridization, it is Sp3 D2 hybridization. See the first example, that is Fe F6 3 minus. Fe F6 3 minus. Here Fe having the atomic number 26, electronic configuration, argon core completed, 4s2 3d6. Fe3 plus, it is the oxidation state, and so that Fe3 plus ion have the electron configuration 4s0 3d5. See its ground state electronic configuration, there are 5 electrons in the 3d orbital. So 1, 2, 3, 4 and 5. This 4s orbital is empty, 4p orbital is empty, 4d orbital is also empty. So in the hybridized state, it does not use 3d orbital. Instead of that, it uses the 4d orbital, and it shows hybridization, that is Sp3 D2. It shows Sp3 D2 hybridization. Sp3 D2 hybridization. So in the Sp3 D2 hybridization, 1s orbital, 3p orbital and 2d orbitals combine, and it gives the octahedral shape to the complex. See, this Sp3 D2 hybridization, there are the 6 ligands and they can donate the electrons into these hybrid orbitals. So here there is the 6f or ligands, and that 6f ligands can donate the electrons into that empty orbitals, which are Sp3 D2 hybridized. This arrow indicate that electrons of Fe3 plus and cross indicate that the electrons of 6f ligands. So see, here there is the first F, second F, third F, fourth F, fifth F and sixth F. These 3 orbitals from 4d, they remains vacant, and we having the, that is the here electrons from 6f minus ligands, and thus we have the this valence bond picture. When we see the valence bond picture, see there are 5 unpaired electrons. As there is the unpaired electrons, this complex is the paramagnetic. As it is the paramagnetic in nature, it have the magnetic moment. It have the magnetic moment. So when we are going to calculate the magnetic moment, see here n is the number of unpaired electron, it is 5, and that's why we can calculate the magnetic moment. We can calculate the magnetic moment mu as our usual formula, that is spin only formula. Mu is equal to under root n in bracket n plus 2. See here n value is the 5, and so we can calculate mu is equal to in under root n, that means the 5 in bracket 5 plus 2. So under root 5 into 7, so it is under root 35, it is equal to 5.95, and its unit is the Bohr magneton, Bm. It is the magnetic moment for this complex Fe F6 3 minus. Now we are going to see the geometry of this complex. see the geometry of this complex. It is the octahedral geometry. As usual, we know in the octahedral geometry there are the 4 ligands and central metal atom. They are in the same plane. One ligand which is above the plane and one ligand it is below the plane. So here we having this Fe, F6, 3 minus. So it is the Fe, F6, 3 minus octahedral complex. Then we are going to see the second example of this. See, NiNH3 2 plus, NiNH3 2 plus. Here Ni having the atomic number 28. Its electron configuration, argon core is completed, 4s2 3d8. Here Ni shows +2 oxidation state. So Ni2 plus having the electron configuration 4s0 and 3d8. See in the ground state, it shows the electron configuration 3d8, 1, 2, 3, 4, 5, 6, 7 and 8. 4s orbital is empty, 4p orbital is empty. As it shows the Sp3 D2 hybridization, its 4d orbital take part into the bonding which is empty, and so in the hybridized state, see d orbital will be remains as it is. There is no any excitation. Instead of that, it used the 4d orbital for the bonding, and we have the 4s orbital, 4p orbital and 4d orbital. So here 1s orbital, 3p orbitals and 2d orbitals, they combine for the Sp3 D2 hybridization. Now once it shows the Sp3 D2 hybridization, 6 ligands can donate their electrons in that orbitals, and we have the bonding state of Ni2 plus in NiNH3 2 plus. See this, first ligand, second, third, fourth, fifth and sixth NH3 ligand can donate electrons into this, and thus it is the bonding picture. According to the valence bond picture, there are 2 unpaired electrons. There are 2 unpaired electrons, and so that it is paramagnetic in nature. As it have the 2 unpaired electrons, it is paramagnetic in nature. It is paramagnetic in nature. As it is the paramagnetic, here n is equal to 2, and then we can calculate the magnetic moment. Then we can calculate the magnetic moment is by the mu is equal to under root n in bracket n plus 2. Here n value is the 2, so under root 2 in bracket 2 plus 2 is equal to 2 into 4 is equal to under root 8. It is the 2.83 Bohr magneton. Thus this NiNH3 2 plus complex shows magnetic moment 2.83 Bohr magneton, and this complex is the paramagnetic. After this, we are going to see its geometry. When we consider octahedral geometry, in the octahedral geometry, we know metal atom is at the center and 4 ligands are at the 4 corners. Now these 4 ligands and this metal atom, they are in the same plane. One ligand is above the plane and one is below the plane, and thus it have the octahedral geometry, that is NiNH36 2 plus. So it is the structure for this complex. It is the octahedral geometry. For this hybridization, that is Sp3 D2, there are another examples of octahedral complexes. See, FeNH36 2 plus, COF6 3 minus, CrH2O6 2 plus, and ZnNH36 2 plus. Thus, we see here complexes with the coordination number 6 can show the two types of the complexes. First type, the complexes which can show the D2 Sp3 hybridization, and second, the complexes which can show the Sp3 D2 hybridization. See one thing, our next topic is the inner orbital and outer orbital complexes. Before going to see that, when we consider this D2 Sp3 hybridization, these type of complexes comes under the inner orbital complexes, and complexes which shows the Sp3 D2 hybridization, they comes under the outer orbital complexes. We will be seeing in the next lecture. Okay, thank you.